And so this says, find the sum from k equals 0 to n of 3/2 to the k. And so essentially this would be 3/2 to the 0 plus 3/2 to the 1 plus 3/2 to the 2 plus, and it's going to go dot, 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 plus, first the last term is 3/2 to the n. If that were a 5, I'd go from 1 to 5. I'm going from 1 to n. So this becomes 1 plus 3/2 plus 9/4 plus dot, 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 plus, and you leave this as 3/2 to the n because you don't know what n is. So that's what your answer is. So I mean, it's a little stupid. I mean, I do a numerical thing, like find the sum from 1 to 5. Now this goes from 0 to to n minus 1. So this would be 2 times 0 plus 1. And the reason why I do it the way I do it, the set of parentheses, this gives me the sequence generator on the inside. So that says if n equals 0, I have this, plus 2 times 1 plus 1, plus, that's what got me into trouble yesterday because I didn't do it this way, is 2 times 2 plus 1, plus dot, dot, dot. I just get a pattern going. And then to the n minus 1, this would be 2 times n minus 1 plus 1. And that's where it would end. Starts at 0 and ends with n minus 1. So now you clean it up. This is 2 times 0 is 0. 0 plus 1 is 1. Plus 2 times 1 is 2. 2 plus 1 is 3. Plus 2 times 2 is 4. 4 plus 1 is 5. Plus dot, dot, dot. Plus, this is going to be 2n minus 2 plus 1, which is 2n minus 1. This is a representation of the odds. I'm taking the sum of the odds. 2n minus 1 or 2n plus 1 are the odds. 2n is the even. Because any number that you put in, n1 equal 1, 2, 3, n equal any number actually, you double it, it's even. So any natural number doubled or any integer doubled is even. Well, why? It's always divisible by 2 because that 2's sitting in front. So any number divisible by 2 is even. Now I add 1 to it or subtract 1, that's going to make it odd because the one before an even number is odd, then the one after an even number is odd. So you get used to 2n minus 1 and 2n plus 1 being the representation for the odd numbers. And then 2n being representation for the evens. This is the thing I really hated when I was a student, which was taking a sequence that was there, and this actually isn't bad, what you have to do, but this stuff that we ended up having to do. You had to find the pattern, and then you actually had to find the formula, and then you had to write that stupid thing as a sum. And it was hard. For those of you who are going to be taking the engineering calculus, that's engineering calc 2, and that is not fun when you do sequences and series. And that's one of the things that you do. It's like, now I'm going to take a sum, and I'm going to put it into notation. And the first thing you go after is the formula. Then you set that what k is going to be equal to something to something. You just have to figure out what that something is. But you have to find the pattern. 1, 2 cubed, 3 cubed, 4 cubed. Looks like we are cubing the base, right? And the base is incrementing by 1. So if I said k cubed, k starts at 1 and ends at 8. So it's k equal 1 to 8 of k cubed. So if k equal 1, I get 1 cubed, and then 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed. If I'm up here, it's going to be 8 cubed, so it's 1 to 8. Now this is why I think this is stupid, because the only thing that you need to concern yourself about is what k is, because in the end, that's your formula. Just like when we wrote it out, that we had to leave the formula because it was an n. This tells me how that thing was generated. It was generated by taking 2 times whatever k was and subtracting 1. So this would be 2k minus 1 and now the question is, where does k start? I need to have a 1 in this position, so if k is 1, I'd have 2 times 1 minus 1, and 2 times 1 minus 1 is 1, so k is going to start at 1. And then it tells me where it ends. Where is it going to end? 12. That's what I mean. These guys aren't bad. The other ones can get icky, but these aren't bad. Now again, I go to this right here to give me my formula. And I've got to match this, this up to tell me where k starts. So it's the sum from k equal, and I don't know what k starts at, but the formula is negative 1 times 2/3. Now to the 11, we'll say that's to the k, and the 11 minus 1 is k minus 1. So I know it stops at 11, because that's what this is telling me. The question is, does it start at 1? Does it start at 0? I just choose k equal 1. If k equal 1, I get 1 minus 1, and minus 1 to the 0 is 1, so the minus is gone. And 2/3 to the 1 is 2/3, so that gives me the first position, so it's 1 to 11. Last problem of the semester. Woohoo. Or it could be a boo-hoo. Sniff.
We'll miss you.
Right. There's some of you I'm seeing in the fall anyway, so get that opportunity. So the sum, now I need to, this is n over e to the n, so my formula is going to be k over e to the k. Now it stops at n. Now if it had like 11 over e to the 11, it would stop at 11. If it had 5 over e to the 5, it would stop at 5. But the end point is n, so it stops at n. The question is, where does it start? Well, it looks like it starts at 1, because if k is 1, I have 1 over e to the 1, which is just 1 over e, so 1n. But when you're writing it up, your formula is given to you. The kicker of this thing, like I said, well, I hated it so much, was when that formula wasn't given to you and you had to find it.